Compound rigging techniques. So far, we've talked about basic and advanced rigging. Now we move into compound rigging. Compound rigging is where you stop thinking in single lines and start thinking in systems. Because sometimes, one rope isn't enough. Sometimes, one rigging point isn't enough. And sometimes, the safest way to remove a piece is to use more equipment, not less. In this podcast, you'll learn how adding ropes and equipment can actually reduce force and increase control. You'll learn how to set up and remove a static removable false crotch. You'll understand how speedlines work and when to use them. And you'll learn how floating anchors can be combined with speedlines to manage complex situations. Let's start with the big idea. More gear does not mean more risk. Used correctly, more gear means more control. When you add additional ropes, pulleys, or anchor points, you can spread forces across the system. You can reduce the load on any single point, and you can control movement in multiple directions. This is the foundation of compound rigging. Instead of one load line doing all the work, you may have a load transfer line sharing the load. You may have a control line guiding direction. You may have a lowering line managing descent. Each line has a purpose, and together they create a system that is stronger and more predictable than any single line. Now let's talk about one of the most important setups in compound rigging, the static removable false crotch. A static removable false crotch is a rigging point that you install in the tree using equipment instead of relying on the natural structure. Typically, this involves an arborist block or pulley attached with a sling. The rope runs through the sheave of the block. The key difference here is that the system is static. The anchor does not move, and it can be removed from the ground once the job is complete. This is often done using a retrieval system built into the rope. The advantage of a static removable false crotch is control. It provides a clean, predictable path for the rope. It reduces friction at the rigging point, and it protects both the rope and the tree. But it also changes the forces in the system. Because there is less friction in the tree, more force is transferred directly to the anchor. This means your anchor must be strong, and your ground-based friction device must do more of the work. Now let's talk about speedlines. A speedline is a system that allows material to move horizontally instead of vertically. Instead of lowering a piece straight down, you send it along a line to a different location. The speed line is the main line stretched between two anchor points. The load line connects the piece to the speed line, and a control line or drift line may be used to guide movement. When the piece is cut, gravity pulls it downward. But because it is attached to the speed line, it travels along the line instead. This is extremely useful when working over obstacles. For example, if you're removing a tree over a house, a fence, or landscaping, a speed line allows you to move material safely to a drop zone. But speed lines have limitations. They require strong anchors at both ends. They introduce tension into the system, and they can create significant forces if not properly managed. The angle of the line is critical. A steeper angle increases speed. A flatter angle increases tension. So every speed line setup is a balance between control and force. Now let's talk about floating anchors. A floating anchor is a rigging point that moves with the load. Instead of being fixed in one position, it adjusts as the system is loaded. This can be especially useful when combined with a speedline. In a speedline system, a floating anchor can help distribute forces more evenly. It can reduce shock loading, and it can allow the system to adapt to changes in direction and weight. For example, instead of a piece being locked into a fixed path, the floating anchor allows slight movement. That movement absorbs energy and reduces peak forces. Now let's talk about knotless systems. A knotless system uses hardware and splices instead of traditional knots. For example, you may use a splice sling, a pulley, and a carabiner, or rescue pulley to create connections. This reduces the number of knots in the system. And fewer knots means fewer points of weakness, because every knot reduces rope strength to some degree. Now let's talk about how all of this comes together. Imagine you're removing a large limb over a structure. You install a static removable false crotch using an arborist block and sling. You run your load line through the block. You attach the limb using a bite or a running configuration. You add a load transfer line to share the weight. You set up a control line to guide the piece. And if needed, you install a speed line to move the material away from the work area. Each part of the system has a role. The standing part of the rope carries the load. The working end is used to tie and adjust. The running end moves through the system. As the piece is cut, the system engages. The load is distributed across multiple lines. The pulleys and sheaves guide the rope smoothly. The friction device controls the descent. And because the system is designed to share forces, no single point is overloaded. Now compare that to a single line system. All the force goes into one rope, one anchor, one control point. That system may work, but it is less forgiving. And it offers fewer options for control. Compound rigging gives you options. It allows you to Lift and lower at the same time. Control direction and speed independently. Reduce forces by distributing load. And adapt to complex situations. But it also requires planning. More lines mean more potential for tangles. More hardware means more setup time. And more complexity means more opportunity for mistakes. So the key is not just adding equipment. It's understanding why you're adding it. Now let's walk through a real-world example. You're removing a large limb over a greenhouse. You can't drop it straight down. And there's no room for swing. So you install a speed line. You set your upper anchor high in the tree. Your lower anchor is positioned in a clear drop zone. You install a static removable false crotch at your rigging point. You attach the limb using a load line. You add a control line to guide it. As you make the cut, the piece begins to move. Instead of dropping straight down, it travels along the speed line. The floating anchor adjusts slightly as the load shifts. The system absorbs the energy. The forces are distributed, and the piece arrives safely at the drop zone. That's compound rigging done right. Now imagine doing that with a single rope. The piece would swing. It might strike the structure, or it could overload the system. That's the difference. So here are your key takeaways. Adding ropes and equipment can reduce force and increase control. Static removable false crotches provide efficiency and protection, but require strong anchors. Speedlines allow horizontal movement, but introduce tension and require careful setup. Floating anchors help distribute forces and absorb energy. And compound rigging systems allow you to handle complex scenarios safely and effectively. In the next podcast, we're going to focus entirely on forces. We'll break down exactly how force moves through a rigging system. We'll look at shock loading, force multiplication, and system failure. Because once you truly understand forces, you stop guessing completely, and you start engineering every cut. You've been listening to the Arborist Podcast. Our goal is to grow our collective knowledge, one domain at a time. If you enjoyed the podcast, please like, share, and subscribe to help us keep this momentum. Until next time, let's keep growing this community together.